All right, so for today's focus, we are just going to learn or discuss, kind of review, because you guys have already been taught this in 6th grade. Some of it was even taught in 5th grade. But we're going to be talking about how you can solve, graph, and interpret inequalities. We're focusing just today on 1- and 2-step inequalities. And then we'll get into some of the multi-step inequalities, and then a form of inequalities that you have not learned yet. So it will be brand new material to you, but that's called compound inequalities. Those are the and or inequalities. So we'll get into that later on in the week. We will be testing for this next week. Okay, you will be taking a test on this next week because it doesn't need a whole lot of time for it. Okay, so what is an inequality? An inequality just represents a range of values that your variable, I put X, but that your variable can be, so what it can represent. So we have 4 symbols of inequalities. We have what's called the less than symbol, which is easy to identify because the arrow points towards the left-hand side of a number line. So that's where the lesser numbers would go on a number line. So it's easy to see the arrow points in the direction that a number line would flow. So less than goes to the lesser numbers, greater than goes towards the greater numbers or the larger numbers. Then you've got the less than or equal to and greater than or equal to, which just has the line underneath it representing an equal signs value. So it's combining an inequality and an equal sign together. So some of the terminologies that we utilize for less than, obviously you know the basic one. If they say it is less than, then that's obviously a less than symbol. If they say is fewer than, we would use the less than symbol. Is smaller than, is under. So that's one we've seen quite often before. Is below. Those all are good representations for our less than inequality symbol. Then we've got our greater than inequality symbol, which is basically the opposite of what we have seen here, with the exception of one additional thing. So obviously the opposite of is less than is greater than. The opposite of is fewer than would be is more than. Opposite of smaller is bigger or larger. Either one of those would be fine. Opposite of it is under would be it is over. Opposite of is below, it is above. And then we do have one additional one. If we say that it exceeds, so if I say you've exceeded my expectations, that means you've gone above what I expected of you, right? So when we say that something is exceeding, it means it's going above what was expected. It's not equal to what it's expected, it's just above it. If I say you met my expectations, then you did exactly what I thought you would do. All right, then we've got the less than or equal to. So those are the phrases that we talked about last week. Those are the ones that have some issues for some people, where you might be misguided by the terminology because it kind of has an opposite effect. Obviously, we have is less than or equal to. If you see that, then automatically you know it's less than or equal to. That's the obvious, Captain Obvious there. But then the ones that seem to throw people off. Is at most. A lot of people see the word most and they automatically think greater. But is at most means that's the largest it could possibly be. So that means it can be equal to this value, but it can't go over it. So it could be less than that value. Less than or equal to. Is no more than. Again, everybody sees the term more than and they automatically think greater than. But when we say it is no more than, then it's the opposite of a greater than symbol. The opposite of a greater than symbol is a less than or equal to. Okay, if it's not greater, then that means it's equal or less. Just the same as the opposite of a less than symbol is the greater than or equal to symbol. Some people get that confused. They think the opposite of less than is just greater than. But it's not. If it's not going to be less than this value, then it means that it can be equal or it could be greater, and vice versa. And then again, another one that throws people off, maximum. These are all terms that seem to be a very large value, so a lot of people seem to gravitate towards the greater than sign, but it has that opposite effect, less than or equal to. So is at most, is no more than, and maximum. Those are the ones that people get confused on the most. You want to make sure that you understand that that means it's less than or equal to. Then we have its opposites, are greater than or equal to. So it is greater than or equal to. They do not often put that as the terminology when they're looking at word problems. Most of the time they're going to say things is at least. You must be at least this tall to ride this ride. You must be at least this age to see this movie, and things like that. You must be at least 25 years old to rent a car. Okay. Is no less than. So again, that term no has that opposite effect of less than. Okay, and then minimum. All right, with the idea of these terminologies, you are able to figure out from a contextual problem what kind of symbol is going to be utilized. All right, so now with graphing, just as a reminder, when we graph, if it's just a less than or greater than symbol, then we graph with an open circle. That open circle indicates that you start there, but you don't include there. I start graphing at the value of 7, but I don't include the value of 7. Okay? So if I'm saying something like, we'll stick with 7. If I say that x is greater than 7, then that means when I've got my number line and I've got 0 located here, I've got 7 located here, above the 7, I'm going to put an open circle to indicate that I'm starting my graph at 7 but not including it. And then because it's a greater than symbol, am I going to go to the left or to the right? To the right. Remember, it's very important that when you are graphing, you want to make sure that your variable is on the left side. The reason for that is because when we're looking at our inequality statement, if our variable is on the left side, our inequality sign is pointing the direction that your graph is going to go. If your inequality, if your variable is not on the left side, then your inequality is pointing in the opposite direction. Okay? All right. If it is a closed circle, then that means it is including the value, so it's going to have that equal sign underneath it. So if I had something like x is greater than or equal to 7, then that means that that same graph where I've got 0 and I've got 7 located here, this time I'm going to have a closed circle. I have to fill the circle in to show that I am including 7 as part of a solution. And then I'm showing my graph that I'm going to continue on in the direction of the greater values. Now something you want to be mindful again, I'm going to highlight it, always graph with your variable on the left side. If you have 4 is greater than x, you can rewrite this. You can rewrite by flipping the entire inequality statement. So instead of 4 is greater than x, you would say x is less than 4. X is less than 4 if 4 is going to be greater than x. Okay, that means that this graph, if we've got 0 here and 4 is located here, it would be an open circle at the 4, and we would be graphing it to the left. Again, If your variable is on the left side, your inequality is pointing in the direction you go. If your variable is not on the left side, your inequality is pointing in the opposite direction. So always get into the habit of putting your variable on the left side. Before you even solve, if you see that your variable is not on the left, flip the whole thing. All right, go ahead and flip it on over to the back. Let me know when you got it, Caleb. Thank you. All right. So taking a look here, I want you guys to go ahead and practice graphing. You're going to practice graphing these inequalities. If you need to rewrite, then rewrite by flipping first before you graph them. And then for problems 5 through 7, what you're going to do is you're going to identify the inequality. You're going to say, oh, x is greater than, or x is less than, or x is greater than or equal to, or x is less than or equal to, and then what point does it start at? That would be the value that it's greater than or less than, or greater than or equal to, or less than or equal to. So do problems 1 through 7 on your own. They should not take you too long. I'm going to give you 2 minutes. All right, for problem number 1, x is greater than 1. Is that an open or closed circle? Open, right? It's got the greater than sign. It does not have an equal sign underneath it. Is it going to go to the left or to the right? To the right. We're going to be graphing it to the right. So starting at the value of 1, we're going to do an open circle, and we're going to draw a graphed line to the right. Okay, what about for problem number 2? I've got negative 2 is greater than or equal to x. The first thing I should do is flip it, right? I want to go ahead and rewrite it. So we're going to rewrite by flipping. So this is going to be x is less than or equal to negative 2. X is less than or equal to negative 2. Open or closed? Closed. Left or right? Left. Okay, so it's going to go to the left. So starting at negative 2, we're going to do a closed circle, and we're going to graph it to the left. Okay, problem number 3. Again, first thing I need to do is flip it. I'm going to go ahead and do a rewrite. So it's going to be x greater than or equal to 5. Open or closed?
Closed.
Closed. Left or right? To the right. Closed and to the right. Okay, so we're going to have starting at 5. Oop, and I did it in the wrong color. My bad. Starting at 5, it should be a closed circle, and we're going to go to the right. That should have been pink. My bad. Number 4, x is less than 4.5. I don't need to rewrite. Open or closed? Open. Left or right? Left. Okay, starting at 4.5. So that's in between the 4 and the 5. It's going to be an open circle, and we're going to go ahead and go to the left. Okay, so there's what our graphs should look like. Taking a look at problem number 5, it's an open circle, and it's going to the right. It's an open circle going to the right. So what kind of inequality is that going to be? Less than, greater than, less than or equal to, greater than or equal to. Mason. Very good. X is greater than, that's a greater than symbol, and it started at negative 1. Okay, problem number 6. We have a closed circle, and it's graphing itself to the left. So we're going to have x is what? Equal. Good. Less than or equal to 2. Okay, problem 7. We've got an open circle, and it's going to the left. So it's going to be x is what? Who can raise their hand tell me? Kaden. You're going to have to know how to say it. Very good. X is less than 7. X is less than 7. All right, go ahead and flip it to the next page. Solving. So the only thing that's different with inequalities versus equations is the negatives. When you are encountering a negative value, a negative integer, if it's multiplication or division, things get tricky. Okay, so when we take a look here, if I've got the inequality 12 is greater than negative 8, and I multiply it by a positive 2, I get 24 is greater than negative 16. That's a true statement. So when I multiplied by a positive 2, nothing affected my statement. 12 was greater than negative 8. Multiplying both sides by 2, I still get an inequality that's true. 24 is greater than negative 16. However, if I decide to multiply by a negative 2, so 12 is greater than negative 8, right? Positives are bigger than negatives. But if I multiply by a negative 2 on both sides, that 12 now becomes negative 24. That negative 8 now becomes a positive 16. Is my greater than symbol still true? No. That becomes a false statement. Okay? So what happens is if you multiply by a negative or divide by a negative, you have to flip the inequality symbol in order for the statement to stay true. Let's write that down. Okay, when you multiply or divide both sides, that's important to understand. When you are multiplying or dividing both sides, that's what we do when we're trying to balance our statements, by a negative, the inequality reverses. Just the sign, the inequality sign reverses. Greater thans now become less thans. Less than or equal to's now become greater than or equal to's. You're just reversing the sign. You're not flipping the whole statement. Okay, I'm not going to flip this and make it 16 is less than negative 24. That still would be false. You're only reversing the actual inequality sign. So negative 24 is less than positive 16. We have to reverse it. That way this now becomes true. Okay, and like I said, it is true if you were to divide. It's not just multiplication, it is also true for division. Okay? So when you divide by a positive, your inequality would stay the same, but if you divide by a negative, your inequality is going to reverse. Okay, go ahead and flip it on to the next page. So for these problems on the next page, all we're going to be doing is solving inequalities. I don't want you to worry about graphing for right now, just because I want to go ahead and focus on the solving portion itself. So when we are solving, if you multiply or divide by a negative, okay, if you have to multiply or divide by a negative in order to isolate your variable, that's going to cause you to reverse the inequality sign. Don't forget to do the rewrites for any inequalities that have your variables on the right side. You want to rewrite before you solve. Okay, so taking a look at problem number 1, we've got x is minus 7 is greater than or equal to negative 12. X minus 7 is greater than or equal to negative 12. You still solve it the exact same way that you would solve if it was an equation. In order to get x isolated, what inverse operation do we need to perform to both sides to isolate our variable? Addition, right? We're going to add 7 onto both sides of that inequality wall. We're going to add 7 to both sides. Okay, so the x will now be isolated. I'm adding, so that has no effect on my inequality, so my inequality still stays a greater than or equal to. And then negative 12 plus 7 just becomes negative 5. Okay, if I were to graph that, that would be a closed circle to the right, starting at negative 5. Okay, taking a look here at problem 20, I'm going to rewrite it first. Sorry, not 20, 2. Problem 2. I'm going to rewrite this first because I have my variable on the right side. So I'm going to rewrite it so that I have x plus 5. I'm going to flip the inequality to a less than symbol, and then a negative 20 is going to go on the right side. So I'm just rewriting by flipping the entire thing. Now I can solve. What inverse operation am I going to perform, Cole? Subtraction. We're going to subtract 5 from both sides. That leaves x isolated. Your symbol is not going to change at all because it's just subtraction. Subtraction has no effect on our inequality statement. Negative 20 minus the 5 is going to come out to negative 25, and then we're done. That would be an open circle, and it would graph it to the left. Okay, if you take a look at problem number 3, I don't need to rewrite. There's no rewrite necessary. What inverse operation am I going to do? DJ. Division. What are we going to divide both sides by? Negative 3. We are dividing by a negative. So remember our rule. I'm going to put a star here. Because we are dividing by a negative, then we need to do a reverse. So this inequality is going to get reversed. It becomes less than or equal to. It becomes a less than or equal to symbol. X is now isolated. Negative 18 divided by negative 3 is going to become a positive 6. And there's our inequality. Closed circle, it would graph it to the left. I want you guys to go ahead and finish off problems 4 through 10. Be mindful of your two-step equations or two-step inequalities. You need to get rid of your constant first before you do any multiplication and division. Okay, so for problem number 4, your inverse operation in this case is going to be multiplication. You would multiply both sides by a positive 7. Again, it's multiplication, but we're multiplying by a positive, so that's not going to have any effect on your inequality. You're going to get x is greater than negative 14. That would be an open circle graphing to the right. For problem number 5, the first thing that I would naturally want to do is to rewrite my inequality by flipping the entire statement. So this becomes negative 5x. Your inequality becomes greater than, and then negative 15. Then I can start solving. Inverse operation is going to be division, but I'm dividing both sides by a negative 5. So that, again, I'm putting my star here because I am dividing by a negative, which means I'm going to go ahead and reverse my inequality. So instead of it being a greater than, it's going to go back to being a less than symbol, and then x is less than positive 5. For problem number 6, I would be multiplying both sides by a negative 5. Because of the fact that I am multiplying, I'm going to be multiplying by a negative. That means, again, I'm going to go ahead and reverse my statement. So this inequality is now going to become greater than or equal to. X would be isolated, and negative 2 times negative 5 becomes a positive 10. For problem number 7, we have negative 20 is greater than x over negative 2 plus 4. Again, my variable is on the right side, so I'm going to go ahead and do a quick rewrite. Yes?
How did you get 5 on number 5? Like,
oh, I'm sorry, 3.
Yeah.
Woo! Thank you. Well, then speak up instead of just sitting there quietly. Okay. All right, so we're going to rewrite. We're going to have x over negative 2 plus the 4 is less than negative 20. That's what our rewrite would look like. First thing that we would do is subtract the 4 from both sides. You're going to get an x over negative 2 is less than a negative 24. Then you would multiply both sides by negative 2. And that's going to cause us to do a flip. We're going to have to flip the inequality because of the fact that we're multiplying both sides by a negative. That now becomes a greater than symbol. x is going to be greater than a positive 48. Okay, so for problem number 8, we don't have to do a rewrite. We can just go ahead and automatically start solving. I would add 13 to both sides first. That's going to leave me with a negative 2x. That minus sign comes down like a negative 2 now. Negative 2x is less than a positive 24. We would then go ahead and divide both sides by a negative 2. But again, because of the fact that we're dividing by a negative, that's going to flip this inequality. It becomes greater than or equal to. So we now get x is greater than or equal to negative 12. Okay, for my last two problems, problem number 9, we have 0.6x plus 8 is less than 23. First thing we're going to do is subtract 8 from both sides. We're going to get 0.6x is less than 15. Then we're going to go ahead and divide both sides by 0.6. And Caleb, tell everybody what you discovered again. What happens when we divide by a value smaller than 1?
The answer goes up.
The answer goes up. And what does the answer become?
25. X is less than 25.
Okay. Any questions? All right. For here, number 10, we're going to go ahead and subtract 14 from both sides. That's going to leave us with 6x is greater than or equal to a positive 6. And then we would divide both sides by 6 and get x is greater than or equal to 1. All right. Loaded in Google Classroom is your assignment. It is a Delta Math. The first two parts of the Delta Math are timed. You have to get 10 correct answers in 100 seconds. They are not hard. 100 seconds. 10 correct in 100 seconds. Once you get the 10 correct, you want to hit stop on your timer. If you don't hit stop on the timer, it's going to keep going.